Good evening. When I think of building kits, I immediately think of two things. One, what a headache to keep track of all those little parts. And two, it's got to pass the cute factor. Tonight, Gary N9UUR is going to be talking about the QRP Labs QMX Plus transceivers kit, um, with some input from W9PEM, W9MXQ, W9DHI, and W9XT. So, Gary, please take the floor.
Okay, so yes, we're going to talk about building this little transceiver kit, which is this little unit over here. Currently, it's running. Well, I'll go over that at the end of the presentation. So let me bring up this. So this is the QRP Labs QMX Plus transceiver. It's pretty small. There's a view on the inside. We're going to get into a bunch of pictures of the inside guts of it later. It is designed and built by Hans Summers, N9UUR, who owns and runs QRP Labs. He's in the UK. And if you go to his webpage, just Google QRP Labs, it'll come up. He has a ton of kits. Very interesting stuff. And the biggest one is now the QMX Plus. The QMX Plus is 160 meters through 6 meters all mode transceiver. It will do CW, digital modes, upper sideband, lower sideband. And it's $125 for a kit. Now, it only puts out 5 watts, but it's pretty amazing for everything it does. It's got a whole bunch of features, self-diagnostics built into it. You can hook it up. You hook it up to your computer and go in and you can do self-diagnostics. It'll tell you what it's putting out power-wise on each band, et cetera, et cetera. So we'll get into that later. So it's a ton of features. I'm not going to read this list, but this is a partial list of its features. Go to the webpage and read more about its technical capabilities. But some of the other interesting things that it has built-in test generators and signal generators. You can use it to create a signal to go test other gear. You can use it to self-diagnose itself. It also has an internal microphone, so if you're going to run sideband, you can yell at the radio, but we have some options for that later. So the folk who were decided to get together, well, we never really got together, but over email we bounced each other's phone. Paul, W9PEM, built a QMX, which is the predecessor to this. Originally, it was QMX is only CW. And then when Hans came out with new software, it added single sideband and digital modes, etc. So Paul has a QMX he uses, fully upgraded, doing sideband and digital with it. Greg, W9DHI, who's on Zoom, built a QMX kit. Gary, W9XT, has a QMX kit. I built my kit. And Bill, W9MXQ, cheated horribly and ordered the factory assembled model. So he's cheating. So this is what you get if you order the 160, the QMX Plus kit. An enclosure, a motherboard, and a big bag of parts. The motherboard, you see on the right lower there, all the LSI integrated components come pre-soldered to the board. So you're not working with microchip stuff. You're just working with discrete components. And this is the QMX kit laid out that Paul made. The manual and the documentation that comes with this, it's a big bunch of PDF documents you download from the webpage, I think is quite excellent. It made sense to me. I could follow it very easily. Full schematic of the receiver, of the transmitter, and of the motherboard. Again, the motherboard there's a USB port, USB-C, the latest version of USB, on the back of the radio. You plug it into your computer and you put the radio with 2 clicks of the front panel into USB mode, and it presents itself as a flash drive to the computer. So you download the latest firmware, you put it on the radio, you reboot the radio, and you're the latest firmware. He is currently still supporting, upgrading it, etc. The latest firmware was released on December 3 of this year. So he's continuing adding, fixing bugs, etc. So the documentation also, I won't read this, extensive parts list, how many parts you should have of what value, and then on the schematic, what the value of the part number is, so you know where they go. Also extensive pictures of all the parts so you can see what it should look like when you're trying to pick out which torad. Torads are the problem with this rate. Well, not the problem, but yeah. So you have so many parts that I recommend, and what I did is I got out my parts tray from the garage. So you can sort things. The white tray on the top I used to put all the torads in, and actually wrote little post-it notes and labeled each one. So parts tray is a must when you're dealing with a kit of this size. The manual then goes and shows you pictorial diagrams of the motherboard and exactly labels where each part should go on the motherboard, and takes you through step by step by step with each part. You'll see on the right here, there's a couple in red. Those are the power transistors going in. On the bottom, a couple of pictures showing you what they should look like when they're installed. The biggest time spent for me was winding the torads. And it has a lot of good information about pictures of what the torad should look like, how to go about winding directions, and then pictures. Here's on the bottom right is a red torad going in, showing you exactly where that one goes. You wind them one at a time and install it so you don't get everything goofed up. So yeah, placement is clear where the torads go. I found using my little pin vise, I put a blue piece of wire insulated and clamped it down tightly with the vise. And that allowed me to use a forceps and start my winding, and then wind through the torad as many windings as I needed. Because there's just no way you're going to hold the torad in your hand and try to get this, it's never going to work. So you need to devise some sort of method, and this worked really well for me, of holding it down so you can wind them. And there are 21 of them you need to build. So yeah, many evenings spent in the basement just winding torads. But on the left here is one I built. I think it looks pretty nice. And then it went into the board, and then yeah, there's 21 of them there. I actually went as far as to create a spreadsheet because it was hard to look back and forth between the torad part number and the part on the board, which is a, item number on its, what torad, So I finally said, made this spreadsheet, which is part number, what core is used to make that part number, how many turns go, how many turns of wire go through that torad, is there a tap or not, and then figuring out how long a piece of wire do I need to, because you don't want to work with the whole spool, cut a piece of wire to roughly the right size. And then if I got totally confused, I could tell that was on page number 27 or whatever to go look for further information. So this little spreadsheet helped me a lot. So once you're done, then you create the front board. It has a real nice LED display, lights up, etc. The back panel is your antenna connection. It's optional, but I have it, have a GPS receiver in it with a little hockey puck receiver antenna it comes with. That will, it uses it to set its frequency. So if it's a dead on frequency, it's not going to drift at all. It also uses it to set real-time clock internally. So if you're doing WSJT digital stuff, you're on timing. And the USB port, it has a separate PTT if you want to use a foot switch for single sideband, and the DC input. So mine is there and all done and all put together, and you apply power and it works the first time. Okay, I got some chuckles out of a few people here. No, it doesn't work the first time. Then you go back and you find, two solder joints that are maybe globbed together, and you check it over 3 or 4 times, and then it finally works. So you can build this kit to either work with a 12-volt power supply or a 9-volt power supply. It'll still put out 5 watts max, depending on which power you want to build it for. The issue, however, is you do not want to exceed that voltage because you'll blow up the finals. If you put 13, 14 volts into a 12-volt build kit, you're risking blowing it up. Yeah, for a little while, you're going to get a little more power out of it, but it's built to do 5 watts. And if you're trying to run it at 6.5, that's not a good thing. So I was thinking this through, and I'm got this to go play POTA at some point. And right now, I'll show you later, guys, Zoom people at home. But right now, it's sitting here running off of this battery. And the battery, a 12-volt battery, well, when it's fully charged, what do you get out of a 12-volt battery? Could be approaching 13. And then as the battery is used, it goes down in voltage and maybe gets to 12 eventually, and then it goes 11.5 and down to 11, as you're using it up. So that wasn't a good idea, but I want to be in the field running a battery. If you plug it into your car is 13.8. So that's not a good deal. So I have purchased for $29 something called a buck boost power supply. It's the item on the left here. You can input voltage of 6 volts to 36 volts. It'll take an input range of 6 to 36. And then it is adjustable with the dial on the front to output a voltage that you choose. So I have adjusted my buck boost to put out 9 volts. So I'm feeding it with, and then on the right, I also got this little voltmeter. So right now my battery is putting out 12.3 volts. My buck boost is dropping it to 9. It also will limit the current. So the radio at max current draw is going to take about 1.2, 1.3 amps. So I am limiting my current to 2 amps max, just in case something goes wrong. Well, I'm not going to totally destroy it. So the buck boost limits my voltage and my current. So now I can run my 12 volt charged up to 13 volt battery, but I'm only feeding 9 volts to my radio. So I'm good to go. The other issue is I found it does present a DC voltage on its microphone input line, sort of like what ICOM style. And I'm a Yaesu person. So all of my Yaesu discrete microphones, I ended up with a pretty low audio level. So I had to go buy an ICOM type headset. Paul, PEM, has built 3D printed. He bought this microphone and 3D printed a little handheld unit here for a microphone for his. And he actually sent this design and sent one of them to Hans in the UK. And Hans was like, this is really cool. And now it's on Hans's website as an available option, or not. You can't buy it from Hans, but he lists where you get the 3D printed thing for your 3D printer. What do you call those? I don't know. And where you order the microphone from and the parts list, etc. Well, and also here's Paul. He has been out running POTA with his QMX. So these are first time I turned it on, readings from my transmitter. This is taken from, you go in and there's a diagnostic screen which will pop through all the bands and tell you exactly the power output, the current draw, and the voltage of the main voltage regulator on each of these bands. So this is it diagnosing itself. And I copied that in here. After some tweaking, you'll notice like down on the 12 meter band, I was only getting 1.8 watts of power out. After some actual physical tweaking of the torads, like twist one a little bit to the left and one a little bit to the right, and maybe this one needs to lean over a little bit, and this one needs to stand up straight. You go through and you like literally tweak the torads, and I've gotten a lot better power output on all of those bands. So then I took it out in the backyard and I got this. HRO is selling this. I don't know exactly who makes it. They're selling it as HRO brand, but this is called the Soda POTA 150. It's out there on the balcony trying to work right now, and it's not doing a very good job. I just stuck it in a snowbank and it wants to be grounded, So anyway, it comes in this nice case. It all, unscrews. And then in the bottom right here, it'll work on 5 megahertz to 54 megahertz, but only one band at a time. So Tom and I set it up earlier this evening, and then you have to use the spectrum analyzer, antenna analyzer, and you go out and you adjust this little red slider for the best SWR on the frequency you want to use at this point in time. So you got to move that slider a bit for every band you change. But otherwise, it's a pretty nice antenna. Working with it in my backyard, this is the first ever Q I made with it to New Jersey, to Mike. I actually emailed him and I said, thanks for the Q, it's first time Q. And he's like, I'm going to send you a card. So that was very nice of him. But this was the first Q, was Brown Deer, Wisconsin to New Jersey. So Tuesday I was testing, making sure it all still worked, testing from home, and made a QSO with Greg. And this is Grid Tracker. All the red squares are, forget them. The blue dots are of interest. The blue dots are showing me from PSK Reporter where my signal was heard. So my little 5-watt transceiver, I transmitted 3 times, 5 watts. One was, hello, Greg, this is the N9UUR. He sent a signal report. I sent a signal report back to Greg, second transmission. He said, Roger, Roger, 7-3, and I transmitted 7-3. So that's 15 seconds apiece, 3 transmissions, 45 seconds of transmit at 5 watts, and I'm heard almost nationwide. So we were going to do a demo, but the antenna is out there on the I can do this. I'll show you what we're not going to do. So this is my desktop. You can see I'm running WSJT. I have been since before the meeting. The antenna is sticking in a snowbank and it's really not grounded too well or something. And as you can see, it's not really picking up anything too well. We can just for yucks try to enable the transmit, but I'm sure Greg's not going to hear me. So now it's transmitting. The yellow lines here transmit. You can see in Grid Tracker, it's drawing a little red line over to Greg's house. And that red line coming under there is Greg calling CQ, but obviously he's not hearing me. So that's the big demo of the evening. I hope you enjoyed it. Otherwise, it's time for questions, if any.
Gary?
I have a, go ahead.
Gary, a question on the taps on the torids. Did you like solder it on one of the windings, or did you pull the winding out and then stick another winding in?
I pulled it, I made a loop of the winding, pulled it out. So I didn't cut anything. You know, the wire goes loop, loop, then it comes out, loops back in, loop, loop, loop some more. And then at the end, I cut that, twisted them together to make the tap. That makes sense?
Makes sense. Great. Thanks.
You got to unmute yourself, Ron.
Question, WB9RQR.
Hi, Stan.
Why would you want to use 9 volts versus 12 volts or vice versa?
I thought that through and I figured if I'm using my battery in the field, the battery's going to get weaker and weaker and probably get under 12 volts, get under 11 volts. If I'm still getting 10 volts out of my battery, my buck boost is going to take care of it and I'm still on the air. So
Also, if you run over 12 volts, you'll burn out the finals. The finals don't like it.
yeah. So I just thought it was made more sense to me to run it on 9 volts. So I was never tempted to plug it into something that says, oh, I'm 12 volts.
Gary, Ron on Zoom has got a question. Go ahead, Ron.
Thanks. I'm curious what the assembly time was for the kit.
For me, it was 2 days.
I think he's working continuously. I would go down in the evenings once in a while. I don't know how to add up all that time, but yeah, 20 hours. But most of it was spent winding tar ads.
You're a patient soul.
Question, does your buck boost converter generate any RF?
Not that I've noticed,
Noise.
not at all. No RF on the buck boost.
This is my cheapy buck boost, and this is adjustable 3 to 48N, and you can adjust it. And I've got it set for 9 volts. It's got a little hole in it, but I got 10 of these for $7, and it works just fine.
Greg, what voltage you running yours at?
9.
9.
Yep. And there's the
So
inside of mine.
I'm going to grab this just for the folks at home. So there's the buck. There's the buck boost. And so there's the batteries in the case, and it goes to a power meter, which shows me amperage, wattage, and voltage. So the battery's still currently at 12.28. Then the buck boost clamps me at 9 volts. Whoops, there we go. And then that is connected to the radio. Oh, the radio does not have a speaker in it. There's no audio. So there's an audio out. I don't know if I'm showing this right. I'm going to put it down. There we go. So the audio comes out of the radio. And then I got this little item. This is a USB rechargeable amplifier. There's a volume control in the back. So the radio goes into this amplifier and then powers a bigger speaker. I did that. I was initially real concerned about, well, I could run something off the battery, but then I have more power drain in the battery. The battery's not going to last too long. So I found this. It was cheap. But that's about it from me.
Any other questions? No other questions.
Okay.
Oh, one more.
That cost for the basic QMX.
The kit is $125. Assembled, it's $185. And after I bought a buck boost, a meter, a little amp, and a Heil headset, don't tell Jeananne, but I spent twice as much on accessories for this thing than I did for the radio. So,
Well,
This is a safe place, my friend.
it's a good thing. I think it passes the Q test
all right.
because then accessories don't matter.
Accessories can be used for other things, you know. Okay, thank you.
Thank you, Gary.